Assalamu alaikum. Hope you have studied well the first lesson. In this video, we're going to take the first part of the second chapter, linear momentum. At the end of this video, you're going to be able to define the linear momentum of a particle, of a system of particles, and of the center of mass. Apply the general form of Newton's second law. Verify the law of conservation of linear momentum. Apply the law of conservation of linear momentum in collisions, explosions, etc. Mainly in this part, we're going to talk about the first objective. We're going to define linear momentum of a particle, system of particles, and the center of mass. Let's remember first from the last year the center of mass of a system of particles. When a system is formed of particles of different masses, respectively m1, m2, m3, we used to express its position vector as r vector, g equals to m1 r1 vector plus m2 r2 vector plus etc. over the total mass. While making derivative for r vector gives the velocity of the center of mass, which is written as v vector of g equals to m1 v1 vector plus m2 v2 vector plus etc. over the total mass. Also, if we made derivative for v, we will have the acceleration of the center of mass, which is written as ag vector equals to m1 a1 vector plus m2 a2 vector plus etc. over the total mass. Multiplying the sum of m1 plus m2 plus m3 with a vector gives for each ma the sum of a force according to Newton's second law on each particle. So mag vector equals to f1 vector plus f2 vector plus etc., which is the sum of f external plus f internal inside the system. Sum of f internal is given 0 by the principle of interaction, so Newton's second law for a system of particles is given by sum of f external equals to m a vector g, and this is called the center of mass theorem. Now, what is linear momentum? Before we start, let's think a little. Which one is easier to stop? A bullet moving at a high speed or an elephant moving at a low speed? Let's check it. It is difficult to stop the bullet, which is relatively faster than an elephant, which has larger mass relatively. Rest in peace, boy. But also this elephant was hard to stop it. We conclude that the mass and the velocity play a major role in studying motion, and this gives us the definition of linear momentum, which is a physical quantity that informs us about the difficulty of stopping or changing the direction of a moving object. The linear momentum then of a particle of mass m moving with a velocity v can be expressed as p vector, the symbol of linear momentum, equals to the mass of the system times the velocity vector. P and v vector should have the same direction because they are collinear, and the unit of p is given as kilogram meter per second because m is expressed in kilogram and v is expressed in meter per second. Let's solve this application. A car of mass m equals to 1,200 kilograms moves horizontally with a velocity v vector, whose magnitude is v equals 25 meters per second. Determine the linear momentum of this car and deduce its magnitude. First of all, the expression of the linear momentum is given by p equals to the mass times the velocity vector. In this exercise, they gave us the magnitude of the velocity vector, but we know that v vector is written as v dot I vector. Let's replace 1,200 times 25I equals to 30,000 I vector. This is the linear momentum vector. Its magnitude is given by 30,000 kilograms meter per second. Another application, a ball of mass m 0.5 kilograms strikes a rough ground and rebounds with a speed v equals 10 meters per second. Knowing it makes 30 degrees with the ground, determine its linear momentum vector, p vector. This is the graph that shows the velocity vector that makes 30 degrees with the horizontal. We can find that this velocity vector has projections along x and along y. We should take these projections into consideration to calculate the linear momentum. So P vector equals to mass times the velocity vector. The projection of velocity vector is V cosine 30 degrees along x because Vx is adjacent to alpha plus V sine 30 degrees J because Vy is opposite to alpha. Replace m, v, and alpha by their values. We will get the linear momentum vector as 4.33 I vector plus 2.5 J vector, and it is expressed in kilogram meter per second. Don't forget to write the unit all the time, even if you are studying the vector, just put it in brackets. Consider a system formed of two scaters, respectively of linear momentum, P1 vector equals to m v1 vector, P2 equals to m v2 vector, and they form one system. The linear momentum of this system is simply the sum of P1 plus P2. If I have more than two particles, we say that the linear momentum of a system is the sum of the linear momentum of each particle. Whereas for any system, there is a center of mass of position vector r vector g equals to m1 r1 plus m2 r2 etc. over the total mass, as we have mentioned at the beginning of the video. So its velocity vector is expressed as m1 v1 plus m2 v2 etc. over the total mass. If the total mass is multiplied by vg vector, gives us the linear momentum of the center of mass equals to the sum of the linear momentum of each particle. Thus, the linear momentum of the center of mass of a system of particles can be written as Pg vector equals to m Vg vector equals to the linear momentum of the system itself. As an application, consider two marbles A and B of respective masses 50 grams and 75 grams that move horizontally in opposite directions. Given speed of A as 4 meters per second, B as 6 meters per second, determine the linear momentum of system A, B. We are dealing with a system of two particles, 1 and 2. So P vector of the system is P1 vector plus P2 vector. So write the expression of each one, M1 V1 vector plus M2 V2 vector. Replace the mass and the velocity as vectors. Mass is 0.05 in kilograms. V1 is 4I positive because it is along x-axis, and the mass of M2 is 0.075, where V2 is minus 6I because it's opposite to the direction of motion. You have the right to choose any one of these two directions to be positive. Continue solving it. You can find that the answer is minus 0.25 I kilogram meter per second. It means that linear momentum of the whole system is of opposite direction with respect to the positive x-axis. Deduce the velocity of the center of mass of the above system. Pg equals to P of the system. So write instead of Pg m Vg equals to P of the system, and P of the system is found to be minus 0.25 I. The mass of the system is the addition of 0.05 plus 0.075, and by calculation you can find Vg vector as minus 2I, of course in meters per second. In this video we have taken two new ideas: the linear momentum of a particle as P vector equals to mass times V vector. The linear momentum of a system of particles is Pg vector equals to m Vg vector equals to the linear momentum of the whole system of particles. This is the end of part 1. Take notes and study well.